11.3, we are going to work in the polar coordinate system now. We are going to start first on learning how to graph on a polar grid. So all along you have, up until now, been graphing on a rectangular plane or a Cartesian plane. So you would have a x and y axis. So let me draw this right here, for example. Here's an x and y axis, and there are some increments you would count on the x-axis as well as on the y-axis. And you could identify a point by giving the x distance and the y distance of any point. So for instance, if I were to plot this point right here and ask you what's the location of this point, you would tell me the point is located at 2, 3, where 2 is the x and 3 is the y. Or I can come over here and say, let's say, what is the location of this point? And you would tell me it is at -1, comma, and the y distance is -4 down. All right. So what we're going to do is move away from that and learn how now to graph on a polar grid. So here's a polar grid. The center right here is like the origin, right? And this is surrounded by what we call concentric circles, all right? And each one of these concentric circles, that was really poorly drawn, each one of those concentric circles are going to represent the radii, okay? So every single time you go further out, however many you go out, count those radii, and that will be your r, okay? So this would be an r of 1, this would be an r of 2, r of 3, and you get my point. As far as angle measurements, you are still going to measure your angles from the positive x-axis, standard position, and your graph, your angle, my apologies, is always still going to rotate counterclockwise as far as measurements go. So always start from standard position and you're going to measure your angle. All right. Now, of course, there are some times that our angles do measure in the counterclockwise, and we know that those angles are going to be negative. But start from the positive x-axis. So as far as how are these points displayed, well, they, instead of x comma y display, they are going to be displayed as a radius comma a direction angle of theta, r comma theta. So we're going to practice plotting given points as you see down below. We're going to plot for first point -1 comma pi over 6. So let's go figure out how to graph this. So always start with your angle, pi over 6. So if you look over here on our unit circle, pi over 6 is right here, okay? So that means the terminal side of pi over 6, so here's my 0, the terminal side of pi over 6 means that from here to here was pi over 6, okay? Now, I'm going to ignore that negative, but that is a 1, saying that's the radius of 1. So if I'm starting from here at a radius of 1, I'm going to rotate to pi over 6, like right there, okay? Because I have to plot on this radius of 1, but I have to stay on this pi over 6. But here's the problem. My radius is negative. So look what I'm going to do. Pi over 6, I'm going to use some color coding here, is this terminal side right here, okay? If my r was a positive 1, I would have plotted my point right here. I would go from my origin and go out 1 unit if it was 1 comma pi over 6. But that's not the case. my 1 is actually negative. So that means I need to walk away from that green terminal side, but I need to stay on that same line, that green line, but off of it, okay? Because it was negative. So I'm going to walk away from the green line and instead put my dot right over here. That would be my A. Okay, that's my A dot. So let's try another one. Even if you're a little confused on that, don't worry. Let's move on to another one. B is 2, 5.6. So let's go to 5.6. 5.6, when we rotate from here towards 5.6, we land at a terminal side right here. Here's my 5.6. Since my R is a positive 2, I get to, from my origin, I'm going to count out 2, 1, 2, and right here is where I'm going to put my dot. Let's put it in black here, and that right there will be my B. So let's take this off and this off, and let's call that B. Okay. Next, let's do C is 4, pi. Let's go to our pi. So where's my pi? My pi is right here. And my radius is a 4. So I am going to count in a positive 4. So I'm going to stay on my 2, 3, 4. I'm going to stay on that imaginary line that I was drawing there. That's my C. Let's go to D. D is negative 4.5, 7 pi over 6. 7 pi over 6, where is it? Is right here. All right. So since my angle is negative, that means I am not going to put my dot on my 7 pi over 6 because it's negative. That means I have to extend out and walk away from my 7 pi over 6 line. So let's just put this here just to help us visualize. Here's my 7 pi over 6 line right here. Okay. I'm not going to stay on this side right here because my R is negative. So I'm going to walk away. So I'm going to walk away and go 4.5 negative. So 1, 2, 3, 4.5 negative right here. Does that make sense? So again, this here is my 7 pi over 6. So I'm not going to touch that purple line because my R is negative. So I had to backtrack. 1, 2, 3, 4.5. So I hope that makes sense. So that is going to be D. Okay. All right, let's go on to the next one. E is 1.5, 4 pi over 3. So 4 pi over 3 is right over here. And it's 1.5. So we're going to stay on that line. My A is in the way. So let's label A on this side. So 4 pi over 3 and it's 1.5. So we're going to go right there. That will be the E. And F is 2 pi with a negative 6. So we need to find our 2 pi. Our 2 pi is going to be, well, if we start at 0 and then you hit your pi and you wrap around, remember 0 and 2 pi are on the same. That's 360, right? So it's a full rotation. So 2 pi, so we're standing here on this side because we started at 0 and wrapped around, okay? Except I wrapped around on a 6. So if I'm here and it's -6, I need to 1, 2, 3, 4, 5 back away from it, right? And so my dot for F would be right there. So those are the points on a polar coordinate system and how you are able to graph. So now you have two different ways of identifying the location of a point. One is the rectangular coordinate system, which you guys know is this one right here, which you've always been doing since day one. And then now you are acquainting yourself with the polar grid. So let's move on. So over here, you're going to recognize some formulas here, and I do need you to make a little correction. This tangent formula should have a tangent inverse theta, arctan. So, oh my goodness, no, what am I doing? Tan theta is y over x, so theta is tan inverse of y over x. So you can write this, and you should be quite acquainted with this from our vector unit and other units, but especially your vector. So please notice here that the formulas you're using here are no different to what you've been doing all along. This is totally right triangle trigonometry. Here they're showing you once again that if I'm trying to get you to identify point P, there are two ways you could have identified point P. You could have identified it as P is at x comma y, or you could have used P is located at r theta. All right. So if you used x and y, that means you would have said some number x to the left, some number y up, and that would have been your x comma y. Or if you were giving me theta, r comma theta, obviously you would have these little concentric circles for a polar grid, right? But your r would be however many concentric circles you counted out, and then this is your angle theta. So either way, whether you use r or theta, it gives you the location of point P. Notice also this formula right here and right here has to do with you recalling your right triangle trigonometry. So if this is my theta right here, okay, so this is the theta on the outside, but if I'm talking about my theta inside my triangle, if this was my theta, and that's really hard to write, let me make my pen a little bit thinner. So if this is the theta I'm talking about, right, if I'm standing at that purple theta angle, this side would be opposite, and this side would be adjacent, and this side would be hypotenuse, would it not? So if I was standing at theta and I said adjacent over hypotenuse, that's x over r, right? So if I did cosine of theta, adjacent is my x, hypotenuse is my r. So if I solve for x, I need to multiply by r on both sides. So this cancels. So x equals r cosine theta. That's where this is coming from. Do you see that? Same thing with sine. If I do sine theta, that's opposite over hypotenuse. Well, my opposite is y, my hypotenuse is r. So if I multiply by r on both sides, y is r sine theta. So that's where that comes from. And you guys know hypotenuse is always found by Pythagorean theorem. So none of this is new to you, all right? So look how this is used in problems such as these. So sometimes you are going to be given polar coordinates and you need to translate them into a rectangular format. So here, as you can see, this is polar coordinates, right? So polar coordinates says that the first space is my radius, so that's my r. And then let me do that again. This is my r, and then this is my theta. So I need you to change it into rectangular form. So I'm going from r comma theta and I need you to convert into x comma y. So using the formulas on the previous page, we know that we're going to look for x first, right? So let's go look for x. And the definition for x was r times your cosine of your theta. So to solve for x, I need to take the r value, which was 5 square root of 3. It was given to us. And I'm going to multiply it by the cosine of my theta, which was also given me to be pi. Now, before you pull out your calculator and whatnot, I don't want you to do that. I want you to just use your unit circle because it's just that much easier. Cosine of pi means that when you go to the unit circle, you are going to go to pi. So here's my pi right here. And cosine means you are going to look at the x value. Cosine is x, so it's -1. So I am going to rewrite what I have here as x equals 5 square root of 3, and cosine theta is replaced with -1, which simplifies to x just being -5 square root of 3. So that's how I found my x coordinate. I'm just going to repeat by finding y using r times sine of theta. Substitute again. It's pretty repetitious. Sine of pi. And yet again, don't use the calculator, just use your unit circle. Sine of pi means the y coordinate at pi, and my y coordinate at pi is a 0. So I'm going to substitute with a 0 for this piece right here. And so y equals 5 square root of 3 times 0, or you can put parentheses, and that means y is just equal to 0. So my final answer is x, comma, the y that I found, and you are done. Okay, so I'd like you to go ahead and try to do the next one without me holding your hand. So pause the video and then come back and check with me and see if you did it correctly. All right, here we go. Let's go straight into it. X is just going to be your r times your cosine of 2 pi over 3. I'm going to leave a little space here. My y is going to be 2 square root of 3 sine of 2 pi over 3. So let's go to that unit circle. 2 pi over 3, where is it at? Let's erase this now so we can focus. 2 pi over 3, do you see it? All right, hopefully you saw it. And here's my 2 pi over 3. So cosine is going to be -1/2, and sine is going to be square root of 3 over 2. So -1/2 and square root of 3 over 2. So 2 square root of 3 times -1/2. Did I do that right? Yeah. And the other one is square root of 3 over 2. Let me do this a second. Let me move this down a little bit. Okay. And then this one here is going to be y equals 2 square root of 3 times square root of 3 over 2. Okay, so simplify. If I look at 2 square root of 3, times negative 1/2, that's like saying 2 over 1, by the way, right? And so my 2 is in the numerator, and that can cancel with this 2 in the denominator, which leaves me with x equals square root of 3 times negative 1. So my x is negative square root of 3. Over here, same idea. The 2's cancel out. So y is square root of 3 times square root of 3, which is equal to 3. Because square root of 9, square root of 3 times square root of 3 is square root of 9, which is 3. So the answers you should have written were negative square root of 3, comma, 3. And that's it. So I hope you got those. All right. So how about the reverse? If we were to do the reverse, what we're having to do is go from x comma y, and we are going to convert to r comma theta. So we're going to do the complete opposite. And just like in the previous problem, if I move over here, the first thing I want you to do is find your r. So what is my formula for r? Well, r is r squared equals x squared plus y squared. And this was given to be my x and y. So I'm just going to merely substitute. So my r to the second power is going to be square root of 2. And please notice how I put parentheses around it. All squared, and then square root of 2, all squared. Let's simplify. Well, square root of 2 squared gets rid of that. So that's just going to be 2 plus, again, it gets rid of that, which is 4. And if r squared is 4, that means my r is a 2. So I found the first component of that polar coordinate. And now to find my theta, I'm going to do the tan inverse, but just like you guys did in vectors, okay? I want you, whenever you guys are going to find theta using a point, I need you guys to establish which one is the quadrant, okay? Which one is the quadrant? So this one is in quadrant number 1. And if you recall, quadrant number 1, let me see if I can come over here and write this down in your notes. If you do not recall this from vectors, quadrant number 1, you kept the angle. Quadrant number 2, you always added 180 degrees or pi, right? Here, added 180 degrees or pi. And here, you added 360 degrees to the angle you found, or 2 pi. All right. Now this quadrant is in quadrant number 1. So I'm going to put here, let me put it in another color so that we know that quadrant number 1 means we're just going to keep whatever theta we find. So my theta is tan inverse of square root of 2 over square root of 2. And when you type that out, and since they want us to do it in radian mode, if you have your calculator in degree mode for now, just don't forget to convert it into radians, okay? So let's say you have it in degree mode here. You're going to end up with your angle being 45 degrees, okay? And we're going to keep the 45 degrees because it's in quadrant number 1. But we know that our problem, they want us to do it in radians. How do I know? Because right there, that's in radian measurement. So my 45 degrees is, where's my 45 degree measurement? Is right here. It's pi over 4. So theta was pi over 4. So when you type out your answers, for this one, r was 2. My theta was pi over 4. And this is your polar coordinates. So go ahead and pause. And I would like you to try this last one. Or actually, you know what? I changed my mind. I forget that this one was a little bit different. I wanted to bring this to y'all's attention. So notice that in this particular problem, do you see how it has a 0 in the x-coordinate? I want you guys to recognize how much faster these problems are if your x or your y ends up being 0, how fast it is to find your r comma theta. So here's why. So ignore the fact that I asked you to pause the video, just follow along with me here. So let's say this is your x and y coordinate plane, right? And this is your x and this is your y. And if I asked you to give me the coordinates of this point right here on the xy coordinate plane, you would tell me that you would have to go a certain distance to the right on the x-axis, but you wouldn't go up or down, right? So this coordinate will have some sort of x number, comma, 0. Likewise, if you had to choose this point right here, well, you would have to go left on the x-axis, and you would just stay on the x-axis, so you wouldn't go up or down. If it was this one right here, let me put it in purple to be consistent. This point right here, you had to only go up y unit. So you stayed at the origin and you just went up. So that would have been 0 comma y. Whereas this one down here, you would have gone down y units, 0, negative y. Okay, so again, if you start here, you would have gone right x, comma 0, left x, comma 0. Or if you started here and you just went up, then you went positive y. Or if you went down, you went negative y. But what I want you to make a note is that at each one of these angles, you have an angle measurement. This angle measurement is 0, then pi over 2, or 90 degrees, then pi, then 3 pi over 2. Look at your unit circle, and then we end back at 2 pi, right? So a full rotation is what I'm saying. We went a full rotation, just doing unit circle stuff, right? So what I'm saying is this. Do you see this number? This xy coordinate? Which one of these would it have been? Well, since it's a 0 and it's saying to go y distance 4 square root of 3, that means it started here at 0 and it went up 4 square root of 3. It looks like this one. And that angle is already given to us. It's pi over 2. So when you have rectangular coordinates that have a 0 in it, just know that you already know what the angle is. It's one of those 4. So 0 comma 4 square root of 3 is an angle theta of pi over 2. So I'm done with that part. As far as r squared is concerned, that's going to be 0 squared plus 4 square root of 3 squared. Look how easy this is going to be. R squared is going to equal, well, 0 squared is just 0. So I'm going to put 4 square root of 3 all squared. But all we have to do is square root and square root. So r is 4 square root of 3. So the answer is going to be 4 square root of 3, comma, pi over 2. And you are done. And that makes sense because if I graphed 0, comma 4 square root of 3, just for joke, I'm going to show you here. Here's my y-axis. Here's my x-axis. I go to 0, comma 4 square root of 3. Let's say it's right here. There's 0, comma 4 square root of 3, right? And my rotation to that point, well, that is definitely 90 degrees, right? Or pi over 2. Let me stick to pi over 2. So I rotated pi over 2. And what's the distance from here to here? That distance, that distance right there is 4 over square root of 3. So that's your r. That's my r. So visually it makes sense. All right. Hope that makes sense and that you understand. Reach out if you have any questions. Thanks for watching.